All right, Evan Foltz, we are all
Yeah,
set to go whenever you're ready, man.
dig it. Thank you, Josiah. Happy to be here today. Today we're going to talk about, I titled this Complete and Total Soil Nutrition. Sometimes I call it far out fertilization. It's kind of the icing on the cake of the conversation about the physical and mineral realms of bioenergetic agriculture. And it's a particular fascination of mine because it's really a realm where mostly what we have is questions, but the questions aren't being asked in my observation. And it's part of what stimulates me to seek in these realms, because I've just become really comfortable with the concept of, the more comfortable we are with not knowing, the more we know, and really experimentation around these concepts that from a logic standpoint make sense. But as soon as you start asking for proof, it becomes really difficult. And as far advanced as we are scientifically relative to where we've come from and all the value that it's brought, the reality is modern popular science restricts the development of the potential of fertility, I guess is one way to put it. So this is just going to be a bit of an exploration of that. And just to kind of get you thinking a little bit more beyond what's conventional, even organic, and really kind of, maybe get some language out there that can allow us to start talking about it. The limitations of language are everywhere you look. So just a quick note on kind of where we've come from. Justus von Liebig, we talked about him weeks ago, his law of the minimum, essentially that plant growth is limited by the least abundant mineral or element. We're going to take a minute and talk about the different words and what they mean, and try to glean some significance out of that here in a minute. And it's really born of the idea of essential elements. This concept of, if one of these elements isn't present, the plant can't grow, which is really the inside of hydroponic growing, right? If you're going to grow the plant in water, well, in concept, there's always something else in water, but the amount of the elements and the balance that's required for plant growth is not in just your default water source. So in hydroponics, you got to bring the complete fertility in order for the plant to form. But that's essentially all it is what the plant has to have, right? What we really want to be thinking about in the potential of agriculture is what the plant wants. We want to ask the plant this question. That exercise is not folly, just like asking water what it wants. Or, if we think about it from the water and the plant's perspective, how much more can we get out of it, right? So, bioenergetic farming is trying to encapsulate that, not in any kind of rigid, defined way, but just as a manner of having a conversation and then putting that conversation into action to have an experience, and drawing our insight from the result rather than the documented proof of what does work, which we pretty much body slammed at this point in regards to agriculture. So, frequency farming, we're going to talk about trace elements today, but biological growing, all of these things aren't front and center with mainstream agriculture. And that's really what bioenergetic agriculture is attempting to do, is create that conversation and bring it through to action. So this is the concept of essential elements is somewhat debatable. This is a fairly standard script. It doesn't, to my eye, include sodium, which I would consider essential. There's 17 elements here. There are 14 that come from an ionic form, not in the air. Carbon, hydrogen, and oxygen are typically used by the plant through the air. The rest, some can be accessed from the air, but the majority come through the root. So you would see these in a hydroponic nutrient, for example. But there are over 90 elements that are earthbound, that aren't a gas and that aren't man-made. So, the concept becomes, well, what are we missing? And some of the questions that come out of that, when we might imagine, yttrium or some element that's obscure, how do we even source it, right? There's not yttrium sulfate, or, like you can go access micronutrient iron sulfate, manganese sulfate, these kinds of things. So they're not commodities, and they're needed in such trace amounts, and they can become toxic at higher amounts, that it's difficult to work with them individually. So, you seek out rock dusts, sea minerals, things that have known balanced organic forms of these trace elements. And the benefits of those materials are undoubted. That the conversation that we're having is really talking about what the science says. And when the science can't trace what the element is required for, or the mechanism of which it's used in the plant itself, we tend to lose the thread. It's not about all the things in the ecosystem that are helping the plant. I mean, even if a plant doesn't use an element directly, what's to say the ecosystem doesn't need it in order to support the health of the plant? You get what I'm driving at there. So, one way to think about this is requirements versus what the ecosystem desires. It's a bit like, grow the soil, not the plant, right? So how we think about these things defines the net that we cast to bring fertility into our operations, and it defines on some level the nutrient density and nourishment factor of what it is that we're growing as well, which is, again, really difficult to measure. You can throw things out there like the onset of autoimmune and degenerative disease in society and how it's skyrocketing, and point to the fact that, based on USDA data, you need 26 apples today that you would need 1 apple from 1950 based on the amount of iron in it, for example. So we documented this dilution of the nourishment factor of food, but we have there's no smoking gun, right? There's so many variables, there's no way to prove the causation versus, say, what some might say is correlation. I'm pretty firmly in the camp that it's obvious that the dilution of our food, and specifically trace elements, is at the root of that. I'm not going to carry the burden of proof and call myself an expert and go scream from the mountaintops, maybe in a webinar. I guess maybe I am. So, I'm comfortable with that. But at the moment somebody asks me to prove it, how do I, right? Which, if you think that through, is part of the reason we're sitting here pondering to begin with. And so, having said that, a rhetorical question, they're very effective. Why would Mother Nature make an element not needed in the soil? My premise is that she wouldn't. Again, attempting to prove that in some replicable scientific method way is fairly difficult. But we've come up with my company, Progressive Farms, formulates a product called Earth Tonic. And this is a little schematic that we made based on a typical fertilizer that you would see in a big box store, and the elements contained in it. This may have even been the hydroponic nutrient. It's been so long since we made this, but you see all of the elements contained in Earth Tonic. And I should mention, I drank Earth Tonic. Not directly straight, but I use it to remineralize my drinking water. It's food grade. It's sea minerals from 5 different sources, some humified herbs, and it's potentized through implosion to create a synergy amongst the ingredients. It's 5 times more concentrated than ocean water. 1 milliliter is 100 parts per million, so it's extremely concentrated. But it provides every element on Earth that's earthbound in a natural balance. So that's one way of doing it, rather than having to source an individual, bismuth or, any of those other elements that are extremely obscure. Instead of sourcing them individually, you can apply them in a balance. So I'm going to give you some rationale as we go through this, but I want you to think about trace elements. Think about beyond what we know plants have to have, and think about what they want. So here's a way to think about things in a big picture. You got organic growing is about feeding the soil, specifically feeding microbes. The microbes have to be there to be fed. We're going to get into some of that week after next. We're going to start talking about the food web, composting, compost tea, but essentially it's a good way to think about it. A lot of people identify organics as being good for the earth and, not toxic and things like that. That's all well and good, but what it literally means, in my book at least, is that they feed microbes and don't discourage them. Artificial fertilizers feed the plant, most times at the expense of the soil. So think about the soil microbes like the construction workers. They're the ones that put the soil together. They build the neighborhood, if you will. And the organic fertilizers we're using are the building materials. Simple. Something that's kind of not on the radar of this conversation that I like to bring in is the trace elements. Think of them like a toolkit. And if you're aware, microbes don't have a mouth, right? When you have the banana peel in the compost pile, they don't chew on the banana peel. They manufacture and offer an enzyme, a specialty protein that chemically breaks down the organic matter into humus, or the lowest decomposed state of organic matter, or perfect plant food. So that process is not just a happenstance. It's very deliberate. It's accomplished by diverse microbes in the food web. But those microbes that don't have a mouth, that are the primary decomposers, bacteria and fungi, make enzymes, and every element on the periodic table that's earthbound has an enzyme potential. So if you don't have all of the elements in the scenario, compost tea, soil, you name it, microbially speaking, they can't produce all of the enzymes that they're capable of making, and it limits the system. It's like hiring the microbes to build a house and giving them half the tools, right? This concept hopefully makes sense. So trace elements aren't just for the plant. They're also for the microbes that support the plant. So, you know, and this is an image that I've replicated this a number of times. Simple compost tea brew, the identical ingredients. We added earth tonic to the left and not the right. So the increased foam, given the similarity, the identical similarity of the recipes, is a indirect indication of increased biological reproduction. It's protein cycling. Some compost tea brews don't foam. It doesn't mean it's not alive if it doesn't, but this recipe is compelling that the foam is higher on the left than the right, given the same recipe. And after about 4 or 5 hours, you can pour it out into a mason jar, and you can actually see the increased biomass, which you can also identify under the scope. I got an iPhone microscope yesterday, so I'm gonna start giving you some real images here shortly. I'm excited about that. But bottom line is, you know, the trace elements, ensuring that they're all there, catalyzed the situation. It allowed the microbes to do more of what they were capable of. So, you know, just a good example of how, if it's not directly relevant to the plant, it's still relevant to the system. And we really want to take a system approach when we're farming, no matter what the application is. So wanted to just talk about a couple of elements and just kind of, I think it'll bring out some of the significance of what I'm saying. You know, and there are people that would argue that some of these elements are essential elements. I would call them beneficial elements rather than essential, because a plant can grow without them. But you'll see that not only is it about the microbes, but it's about what's eating the plants that do or don't have access to these trace minerals. You know, I say it all the time: if it's not in the soil, it's not in the plants; not in the plants, not in the people. And that's really a mantra. You know, that again, it speaks to really the most pressing issue of our time in terms of the stress on human health, in my opinion. So look at an element like molybdenum. You can test for molybdenum at a lab. A lot of these trace elements aren't even able to be assayed. But molybdenum is I would say beneficial to the plant, plays a critical role in nitrogen fixation by nitrogen fixing bacteria, rhizobia, etc. It's required in the synthesis of certain enzymes, as I was speaking about a minute ago. It's involved in electron transport, plant metabolism. It's linked to a phosphorus uptake. You get some kind of vagary around this because a lot of it is anecdotal. The fact that there hadn't been a third-party reviewed study that isolates with molybdenum and without is really the limitation there. That's typically how the science is conducted. But plenty of farmers will give you anecdotal information about you know, their analysis of soil testing over time, and when they increased the molybdenum relevance, the phosphorus was cycling better in their soil, for example. So it's not required by plants, but animals, it's been documented that they develop hookworm, bacterial infection, you know, other different deficiencies and diseases when molybdenum is not present. This is a lot of what you see when cows seek out weeds in a pasture, or you know, being transferred from fields. They go right for things. They know what they want. They just can't tell us. And a lot of what they get in the trace element realm when pasture is not being fertilized, is that weeds fix high amounts of beneficial deficient elements, and particularly trace elements. And they grow very aggressively, and they die seasonally to deliver what they fix from the air and the subsoil to the topsoil. We're going to talk about that in depth next week. So, you know, these symptoms of not having molybdenum are not obvious, but they can actually appear as a nitrogen deficiency, primarily because of the excess nitrogen or the deficiency in nitrogen that's created by not being able to fix it in the soil. This is where nitrogen fertilizers come from. We're compensating on some level for molybdenum deficiency. So you can see right there, there's bang, bang, all these different angles. I mean, not only does the animal need it, or the plant need it to cycle more, soil needed to fix more nitrogen, so the plant doesn't need to be supplemented. and indirectly through the availability of other elements. I mean, that's pretty critical. So let's look at cobalt. This is rarely measured in soil tests. It can be. Labs can handle this one as well, which is partly why we know so much more about it. I would love to see labs develop. One of the problems with soil testing obscure elements is you have to develop process around that singular element, and it costs too much when you start talking about, well, how do I test for 70 elements? Same with microbes, or contaminants. People want to get a single test that shows all the contaminants in their soil, and not thinking that there's a different process for looking for each one. And where do you start? How many contaminants are out there? It's like a needle in a haystack, right? So again, this one is cobalt's also playing a role in nitrogen fixation. It's considered ideal around half a part per million, toxic above 2. So you can see if you're at, that's a very minimal amount. You might look at adding 5 pounds per acre of something like that. So how do you actually distribute it? I mean, you run into these functional issues as you work through the soil health. And anecdotally, a little understood role in pest resistance. Again, the deficiencies are not obvious. So if you don't have the plant able to tell you that it's struggling in some direct way, and you got to pay extra for the lab to look for it, and there's not really a cobalt access of a mineral, you can see the bind that you're in regards to focusing on cobalt individually. Silica is one that not as many labs test for it. You can get a silica test. It's not considered essential, but man, silica is one of my favorite materials to use in especially controlled environment agriculture, or in any garden for that matter. It's extremely deficient. Even though it's the second most abundant element on Earth, most of it is not available. Like think quartz or sand on a beach. All of this is silica. Diatomaceous earth is silicon dioxide. It's not a bioavailable form. So potassium silica, silica dioxide, and there's other available forms are tremendous inputs for agriculture. You get a lot of the pest infestations that we're getting are the inability of the plant to protect itself through its cuticle. And one of the things that you most obviously get from silica is an increased vigor in the plant, increased rate of cell wall growth, and the thickness of the cuticle of the plant. So literally the pest just can't pierce it. Simple as that. And silica is really big in the biodynamic conversation. It comes through in the horsetail and the stinging nettle. And it's kind of a facilitator of other elements. If you think about it, fiber optics is a silica-based system, computers, and microchips and these kinds of things. So, there's a lot of parallels that you can draw there in that regard. But silica is another element that's not on the direct radar, but that's extremely important in regards to the agronomy there. So just want to take a second and walk through some of these words like fertilizer. Like what is fertilizer? Well, the literal definition is a chemical or natural substance added to soil or land to increase its fertility. I mean, you couldn't get any more vague than that. It's kind of the point, though. I mean, fertilizer, you can pee on something and it's fertilizer, right? So, that concept doesn't really mean anything. It's kind of like saying light bulb, I mean, it makes light, but is it a fluorescent? Is it an HID? Is it an LED? Is it ceramic discharge? I mean, what is it? So fertilizer in concept is also a crutch, and it's important to recognize that. And that's not a negative thing. I mean, it's required. If your exchange capacity is below 7, you have to fertilize to really support plant growth in any kind of yield-based approach. So the question becomes, what's the cost of the fertilizer versus the return that you get? And that's the conversation we've been having for 100 years in conventional agriculture, and we've exhausted the soil's ability to compensate for what we're not adding. So basically we have plants fixing things from the soil in a most abundant way that it can in order to reach its genetic predisposition. And we're adding a fraction of it back in the form of fertilizer. And over time, when we're not adding what's being used by the system and then harvested and eaten by some person, over time you degenerate. And this is the real problem that we're facing now. It's not so much that the fertilizers are toxic directly, but it's like fast food, right? And you make Super Size Me movies out of it, and what happens to people when we eat fast food, and just apply that to Miracle Grow and the current posture of conventional agriculture. So it makes sense over time. It's not that it kills you directly, but over time it creates degeneration in the living system. So, back to what we were talking about earlier, the artificial fertilizers feed the plant. Hydroponics would be an example of that. So with Miracle-Gro or any conventional farming fertilizer, organic fertilizers feed the soil while feeding the plant. It's not like we're ignoring the plant, but if our primary focus is to grow a plant, start a hydroponic system. Separate what your agronomy from the system that you're working in, and you can control it, get a lot better result out of doing that in a much more efficient way. But that's really kind of a way of squaring the difference there. So then you have the term mineral. A mineral is a solid inorganic substance of natural occurrence. Again, typically you would think of a mineral as not being available. It's a bit of a loose vocabulary because I would call completely soluble minerals, take iron sulfate. It's a mineral substance. It's in a compound form. It's not ionic, right? Or table salt, sodium chloride. It's a mineral substance, the compound form. You dissolve it in water, it turns into a sodium and a chlorine ion. Those ions are what plants eat. That's what hydroponic fertilizers are. They break out into the ionic form of the balance that we want based on its use. So the hard part's done for us in that respect. But so you kind of interchange the concept of fertilizers and minerals, and what the literal form of plant food is would be called an ion. And an ion is, and we talked about this a couple of weeks ago, one of many substances that cannot be chemically interconverted or broken down into simpler substances, or primary constituents of matter. So it's kind of the building blocks of the compounds that make up the systems and organic systems that make life and allow life, and the consciousness infuses through the energy bodies that we'll talk about in the energetic realm in the future. And that's a lot of what you're looking at from a broader perspective in regards to biodynamic agriculture. You have a physical realm, what's called an etheric realm, an astral realm, and the I organization, or the ego, which is unique to humans. Animals don't have an ego. They can't see themselves in the mirror. They can't make choices outside of their instinct necessarily. But they retain emotions. They retain, the dream state, etc. And then plants don't have the ego or the astral. They're just etheric and the physical. So when you're using biodynamic preparations, you're influencing the energy bodies. Sounds crazy. Not the physical body. And if you think about it, 99.9% of matter is space. So it gets pretty interesting. But the bottom line is there's many elements that are required for a healthy system that aren't in the typical fertilizer. So this is the periodic table. We're all familiar with it on some level. The atomic number and the decimal points you see, like on manganese and iron, a lot of this is due to what's called isotopes. Now, this is something that's not normally talked about, but the form the element is in can define its ability to be used by the system. So, an isotope is each of two or more forms of the same element. So they contain equal numbers of protons, different numbers of neutrons. And hence they have a relative atomic mass, differ, but not in chemical properties. So a radioactive form, there's uranium in seawater. Why doesn't it give us radiation poisoning when we go swimming? Because it's in a form that nature produced, as opposed to the radioactive form, which is really induced by humanity. So you can see the form of, you can't just say an element. I think there's 3 different forms of magnesium, there's 6 forms of carbon, if I'm not mistaken. I could be wrong about that. But the bottom line is all of these different elements have different postures, which you can imagine creates unlimited variables. And the exercise here is not to figure it all out, but simply to take a moment and imagine the complexity that we might be missing taking a strictly conventional approach to a garden versus the benefit of the diversity that we can bring through more natural materials. So square it like this. You've got the number of elements present. Take a conventional fertilizer, might have if it's a DAP, phosphate, or anhydrous ammonia, it might have as few as 1 to 3 elements in it. Something like Miracle-Gro's got 5 to 7 elements. You talked about the essential elements being somewhere in the 15 to 17 range, 14 to 17, depending on who you talk to. That would be typically a hydroponic fertilizer. And then something like Earth Tonic, for example, would have over 90 elements in it, all in this natural balance. So it's not, though that part of it is fairly well understood. I mean, you can look at it and understand that the greater diversity is going to bring greater potential. But one of the things that we do in our fertility management services is look at the ratio of the elements to each other. This is something that's typically not talked about, other than in progressive agronomy. And then it's the isotopes, the forms the elements are in. Now, all of these things can influence the results that we get when we use different fertilization techniques and products. So I wanted to show it from a different realm. You know, this is a flyer we put together for Earth Tonic a long time ago, and you can see, you know, the hydroponic nutrients going to have. This one was actually Dynagrow, where I got this data from. And, you know, all these elements up are what create the ability to grow plants in water. And you see, which would mean everything a plant requires to accomplish its life cycle. If you notice, the budget fertilizers are missing half of what the plant has to have. So, you know, if you have a big NPK, you can force rapid growth. And to a human that hadn't had this conversation with themselves might think that it's actually a good thing. But the plant's obese. Big plant, no fruit, maybe. But if you got good soil, maybe you get good results with it. But over time, you're going to get more disease, more pest infestations, degeneration, right? So compare that to something like, you know, Earth Tonic's got over 90 elements in it, but notice how low the NPK is. So it's better positioned as a supplement. In concept, you could use both of the Miracle Grow with Earth Tonic and get a lot better results. But you know, you then want to question the source and look at the organic materials, and so as not discourage the microbes. So I wanted to tell you a quick story about a personal pet project of mine. It kind of makes the point on the form of the element. You know, I don't know if you're familiar with water fluoridation, but it's a policy that's been undertaken since around the 1940s, like 45, I think was the first time it was used. But essentially, fluoride compounds, sodium fluoride and hydrofluorosilicic acid, were toxic byproducts of aluminum production and phosphate fertilizer production, respectively. And industry had tremendous amounts of these materials. And you can get cynical real quick in this conversation. I'll try not to, but if you look into the history of this, it's really kind of alarming. But science noticed and industry noticed, frankly, that towns with higher amounts of fluorine in their water supply had less dental cavities, dental caries, as they call them. And so they made the connection between fluorine and reduced cavities, which is part of the reason why it's in every toothpaste and mouthwash you can find, unless you seek elsewhere. I personally have never had a cavity in my life, and I haven't used fluoridated toothpaste for over a decade. It's anecdotal. But what's fascinating is that fluorine and calcium have a very high affinity for each other. The only form that fluorine occurs in nature is calcium fluoride. It's very insoluble, but it's soluble enough to show up in a water supply when you have caliphate soils, like in Texas, for example. So they connected the dot between the higher amount of fluorine and reduction in cavities, but they didn't choose to study the excess calcium that was coming along with it. And what happens is fluorine is now put in most public water supplies in towns more than 100,000 people. They look at it as a cheap way to dose the public to prevent cavities. It seems, you know, like a good thing, but the reality is that it's in a form, a synthetic form, that's highly soluble. And there's a reason we spit toothpaste out. And you know, name one other thing in the human diet that is dosed to us outside of our consent that's considered a medicine. It's unprecedented, and it's also administered indiscriminately. You know, what if I drank 10 glasses of water a day and you drank 5? Would a doctor prescribe twice for me and half for you? So, you know, you get into this and you start asking questions, and it doesn't make sense. And I could probably spend another hour sitting here talking about it, and I'll move on. But the relevance of it is that the form the element's in has everything to do with how it influences the human body. It's not excreted. It binds to our bones because it's affinity to calcium. If your water supply has higher fluorine, it also has higher calcium. And the one way to mitigate fluorine toxicity is through a higher calcium in your diet. So basically, you can mitigate that deficiency. But when you dose it into the water and people don't have good diets, it can create real havoc. So again, the form of the element means everything. We dosed fluorine in my town since 1955. It never has been readdressed by the water system until I started going to the city meetings and asking about it. It's still done to this day. There's a lot of dogma around it. So if you want more information about that, I'm happy to talk to anybody about it. But it's a good example of how the elemental form influences the influence on the living system. So here's a question, can we see the forest from the trees? That's a lot of what we're talking about here. Are we going to pick an active ingredient, or are we going to bring a balance? Again, it's not in the soil, it's not in the plant, not in the people. And I wanted to read a quick passage from the book Secrets of the Soil. This is, for me, a landmark book, and this is the chapter called Clause of Chelation. It's chapter 10, and it's I think it'll speak for itself. So Marbut lamented. Marbut stressed that at the time when Western Europe was still engaged in the futile assertion that soil per se is dominated by the materials out of which it's been built, the Russian workers had long since shown that soil is the product of a process rather than a material, and is therefore not a static but a developing body. They allied soil to life rather than to death. In Marbut's view, Dokuchayev occupies the same position in soil studies as Sir Charles Lyell in geology. Not all this is going to make sense without context, but you'll get the point. Lines in botany, and Mendeleev in organizing the chemical elements into a semi-periodic chart. Marbut lamented that the fact that soils in the United States were looked upon solely as producers of crops, and no discussion of soil development worthy of the name was attempted in any book dealing with their study. The treatment of soils as such is not considered practical, but the subject must be made practical at all hazards. It is outrageous that the whole field of the significance of the soil as a body in plant production remains wholly uncultivated because of the dominance, even in the third decade of the century, of the ideas of Justus von Liebig that completely overlook the fact that the soil lies in the twilight of life as a connecting link between the living and the non-living, between material animated by vital forces and material subjected to physical forces. So the takeaway there is just really a reinforcement of, what we had to do before we could start to have conversations like this. We really had to try to document what we knew. And that was what Liebig was doing. And if you recall in the original talk that we had about this in the mineral conversation, Liebig went, at his death was regretful of the documentation and the limitation of the imagination towards what else could be required for ideal human and animal health. And, I mean, poor guy in some respects. He did some of the most cutting edge science anybody's ever done in the history of the world in regards to plant agronomy. And then he realized that he couldn't put it back in the box. It became the dogma of what it is that we're doing even today. So it's worth some time sorting through some of this, but know that there are people that are treading this path in really compelling ways, and I wanted to introduce you to a couple of them. The inspiration for Earth Tonic was the work of Dr. Maynard Murray. It's a book called Sea Energy Agriculture. This was back in the 1970s. It was a culmination of 30 years of work that Dr. Murray had done, and his original insight was that animals of similar species in ocean environments were much healthier than those in land-based environments that didn't have the mineral diversity in their life, frankly, that you wouldn't find in a pond versus the ocean. So like, seagoing trout never got cancers, and trout in streams did. I was told that now the beluga whales up in Alaska are experiencing cancer, and that I think is an indication of the adulteration of the balance of humanity on Earth. So I don't know if it's directly black and white the way it was in Murray's time, but he made this observation, and he proceeded to set up hydroponic applications using base synthetic hydroponic salts like somebody would today, and supplemented it with sea minerals and got some pretty extraordinary results. Now, admittedly, reading the book, there's more anecdotes in there, and there is some data without a doubt, but the level to which the data was taken can leave a little bit to be desired. I've worked enough with sea minerals to date over the last 15 years to kind of be desensitized to the differentness of it, and can validate 100% the value that it brings. Done a lot of testing with wheatgrass, with and without, taste, and through its ability to heal and things like that. And the biological experiments that I referenced a little earlier, and just from a general logic standpoint. But this book is really fascinating, and I would encourage you to seek it out if you're interested. It was brought back to light by the work of Charles Walters, who's since passed, but he was the founder of Acres USA, if you're familiar with Acres. And he found this research and then republished it under the Acres banner and kind of brought it back out for modern digestion. So, you know, Dr. Murray, he, you know, did his research back in the 30s and 50s. This book was in the 70s. It's, you know, part of what you can draw from this is there hasn't really been, and I say hasn't, I'm sure there has, to my knowledge, that there hasn't been a real complete approach. So to agronomy, and I'm referencing what I'm trying to do with bioenergetics, is, you know, Dr. Murray was real hip on the mineral balance and the nutrition of humans through food, and that was a lot of what his insight was driving towards. But he didn't look into microbes at all. You know, it just wasn't even on his radar. I tried to find some reference of where he connected those dots. It just didn't exist. So, you know, you find a lot of really great insight. The challenge is how to put it all together. And then the real challenge is how to put it into action so that you can present it in a coherent way that's simplified and that's accessible to the average person and farmer. But, you know, you can see some of the results. You know, this is same lettuce crop. It was grown in hydroponics, and this was actually a foliar spray that we were spraying on the plants. And North Tana created a tremendous growth benefit in this application. So, you know, you can see things like that and know that there's some relevance. The question is whether we need proof of its efficacy before using it. And I think that's a lot of the transition that we're in the modern world, not only in agriculture, but in human health. You just look at the attention being drawn towards cannabis and the minefield of the legality, and people are fearful to use it, and the tide is turning. People are saying, you know what, it doesn't matter at this point. I feel written off by the modern medical system, and I'm going to do whatever it takes to heal those that I love. And I think that's just one small example. So it's exciting times. We're going to, you know, I think, be propelled into a lot better understanding of how we can grow better crops to grow healthier people in the next decade, maybe more so than we have in the last 100 years. Would be my hope. So a different way to look into the sea mineral thing is this Quentin C. Plasmy is a French man, and he has a website, plasmaquinton.com. You can look into it. And I use it more as an example. You know, it's a marine plasma. They claim a certain site in the Atlantic Ocean that has a really high. It's a natural vortex. You probably heard about them with the plastic that's accumulating in the Pacific. And he sells it as a dietary supplement, and which, you know, things that haven't passed FDA muster have to be sold in that way. But it's essentially ocean water that's been created with a dilution or concentration based on the concentration of the blood. So you have hypotonic, hypertonic, different solutions. They can be used for different applications, and there's an amazing amount of research done on it and what it's been used to curb in terms of, you know, detoxification, you know, skin clearing, decongestion, all sorts of different things. Yeah, I mentioned I've used sea minerals for over a decade in, you know, purifying water and then adding minerals back, which is my personal preference of how to approach that. And I can't say that I could document the results, but I do feel as if it encourages the health, my health over time. So it's something interesting to look at, just another angle into the same kind of concept is really, you know, why would Mother Nature make elements not needed by living systems? So this is really interesting. This is just a slide that shows you, on one hand, the seeming complication of DNA, but on another, the simplicity. If you notice the adenine, the thymine, the guanine, the cytosine, they only, you know, adenine and thymine combine, guanine and cytosine. If you remember this from genetics or from science class, if not, there's a fairly simple way of approaching it. It's the sequence of these connections and the orientation that define the ability of the organism to create proteins that then carry out the life of the organism, whether it's a plant, an animal, or human. So what you have within that is a very simple structure that you can see is based primarily around oxygen, carbon, and nitrogen and hydrogen. There's not a whole lot of complexity in regards to the DNA itself. But what's interesting is that when you get into the DNA transcribing to make RNA that translates into the protein. The proteins become unbelievably complex and are limited by all elements in presence rather than just what's deemed essential. So there's some really fascinating, I found this book, it's called Minerals in the Genetic Code, another one that Charles Walters at Acres brought out. I found a lot of this around the same time, maybe 10, 15 years ago. I don't remember how long it's been. But I actually met Dr. Olree, who put the information together that's the backbone of this book, the science behind it. Fascinating guy, real mad scientist, you know? And so I just wanted to kind of give you a little bit of his insight, just to let you know that there are people treading these realms. You know, he put together what's called the Standard Genetic Code chart, and essentially what it does is it looks at, rather than what the physiology needs or the DNA needs, it looks into what the amino acids need to make a full spectrum of the proteins, or the amino acids make up proteins. They're the building blocks of proteins. So he traced the elements to their participatory function in the life process. So basically, there's 64 codon potentials of DNA. And based on the posture there, the expression, he looked at the expression of that. And what he deduced was that, you know, in the standard genetic chart, there was an overlay, you know, with an overlay of the mineral involved, he could determine what its absence and connected it to different diseases. And he reversed that and has an index in this book that's really valuable that shows different sources of plants that have the highest elemental expression of that element that he's tracing, and that's defining each of the 64 codons. So essentially, you've got this index of plants where you can access it, and then he backs that into what element is defining one of those 64 expressions of the elemental spectrum. And what I found that was so fascinating when I first accessed it was that he, in the index, you know, I was just getting into biodynamics when I found this, and you look at like oak bark, it's the highest bioavailable form of calcium in nature. And I know that because of this book. Stinging nettle, same thing, you know, highest, I think the equisetum was the highest silica, stinging nettle was up there as well. But what occurred to me is that, you know, Steiner didn't have access to this information back in 1924. His insight brought forward this concept of use these plants for these deliberate reasons. And here's Dr. Olree documenting the nutrient density of these plants, you know, almost 100 years later. And that's really where you find the truth, right? So it really struck me that these different avenues of investigation had parallels. And you can see, the point here is not to figure this out, but just to show you some of the, you know, he did, a lot of his work was based on the expression of the charge of different elements. And there's a lot of deliberate, you know, I'm gonna have to let you get the book and dig into the detail of this if you'd like. But there's a very deliberate, and it actually is not so complicated that you can't understand when you sit there with a minute. That's what a book's for, right? And read through it. You'll come out of the other side, even if you're not hip to chemistry, with a lot of genuine insight. But just here's some of his speak in regards to an interview I found with him. He was asked, can you give us an example of what our body does when a specific mineral is not available? Or say element. You know, again, those words are somewhat interchangeable, even though they mean different things. There's no way to obtain longevity without the proper amount of any mineral needed for the process of DNA. For example, if you get low on boron, the second most abundant mineral in the cerebral spinal fluid, aluminum levels rise, giving way to abnormal transportation of nutrients through the tau transportation system. The problem starts within the pancreas, giving way to abnormal sugar levels that spread to the brain, contributing to the cause of Alzheimer's. Another problem is that testosterone starts to drop and estrogen goes up with low boron levels and is reversed with the addition of boron. So, you know, can we go all the way down the road and say, well, this is what we need to do that? Not necessarily, but fascinating insight, you know, and here's a couple more. You know, in your book, you state that the majority of people are very iodine deficient. What happens when we have an iodine deficiency? Gravity, magnetism, and weak and strong interactions with the genetic code are all maintained with minerals. Iodine has the most electrons and is the heaviest, most important mineral for human life. Everything goes wrong when there's not enough iodine. Cardiovascular disease is prevalent with chronic iodine deficient related problems. Even people with good diets are iodine deficient. If you can get a simple test, kelp is a really high bioavailable form of iodine. But now I've seen practitioners that are naturopathic practitioners do iodine tests on themselves and find that they're iodine deficient. So We'll talk about that a little more depth in just a second. So tell us about the trace mineral yttrium. Yttrium is one of the universe's most abundant minerals, but relatively rare on Earth. It is a single limiting reaction for the reproduction of the biphos species of gut bacteria. These bacteria provide us with the ability to utilize selenium. Yttrium is found in the cerebral spinal fluids. Yttrium's needed by this gut bacteria. This gut bacteria happens to be important in cycling aluminum. So when you have aluminum through pharmaceuticals and through deodorants, and we're using it on sensitive parts of our body, and we're getting all this aluminum in our diet, without yttrium and for the gut bacteria responsible for cycling it, our body doesn't know what to do with it, stocks it away in the brain. Again, this is not proven, but it does make sense in regards to the science that's known. So yttrium is not for the human body, it's for the microbes in our gut, but therefore it's not on the radar of what we need to have in our diet. See what I mean? So you can kind of take that and run with it and start to imagine all of the things that we're missing in regards to the balance of life and how she works. And selenium, when the sun hits the early stages of life in a plant, carbon dioxide, water, and sugar combine to make chlorophyll. Chlorophyll breaks down due to the oxidation of the chlorophyll molecules. Selenium is the master mineral control of the regulatory oxidation in the cell. Again, selenium is not considered an essential element for plant growth. So really interesting to think about. And it gets you into, well, if it's not, if selenium is so important for photosynthesis, and it's not in the fertilizers we're using, and it's not in the soil, where does it come from? If you grow a plant with 17 elements in hydroponics, doesn't the plant end up with more than 17 elements in it? So where do they come from, right? And it's something that's kind of dogged me for a long time because I don't know the answer, frankly. And that's part of this process, is kind of reaching the point of which you don't. But this concept of alchemy is really ancient. It was pre-chemistry, right? It was the medieval forerunner of chemistry based on the supposed transformation of matter, kind of like the free energy concepts today. It's concerned particularly with the attempts to convert base metals into gold, or as a universal elixir, the holy grail, these types of things, which real quick gets into the woo-woo and witchcraft arena. But I wanted to offer you some thoughts that may make it a little bit more tractionable. There's, in alchemy, you have the three primes, they're called: mercury, salt, and sulfur. These are basically materials that are used to create these transitions. And then the four elements: air, earth, fire, and water. And then you work with what's called the 7 planetary metals. And you can see the different planet that's associated with the different metal. It's really interesting. You can do research and connect this to different types of wood, to planets. That's a lot of what biodynamics was doing. It was connecting the planet with the preparation. There's also 7 different chakras for people that are into energetic medicine. So there's really a whole lot of parallel in between how this concept is being applied. And what we've got now is basically the remnant of all of that, which makes it really difficult to understand, because if we've been learning this kind of association in grade school, maybe it'd be a different story, but couldn't be further from this in regards to where we're at in documented science. You can see here's some symbols, the alchemical symbols, and how they line up with the different planets. And it's kind of like thinking about the Maya. How did they tell time, and how did they live in their civilizations as long ago as they did, and with the complexity that they had without the instruments that we use today. It's spend some time thinking about that, and it'll run me around for a bit. But here's another example. I mentioned iodine earlier. The way sodium chloride was originally kind of sold to the public was as to account for goiter and iodine deficiencies, extreme iodine deficiencies. And they started putting iodine in molten salt. I believe it was back in the 1930s, somewhere in there. And it did the trick. I mean, it didn't clear the problem up directly, and here we have it still today. Sodium chloride is one of the most destructive molecules in the human diet, not because sodium and chlorine are bad for you, they're vital for health, but because they're out of balance with everything else. There's enough sodium in a stick of celery that you would use on an average meal, and the doctor's not going to tell you not to eat celery on a low sodium diet, for example. It's going to tell you not to eat processed foods where you get a lot of the sodium chloride, right? So when the plant fixes it, it's within that natural balance. Same with sea salts, right? its sea salts have over 90 elements in it. Sodium chloride table salt has 2, 3 if you got iodized. So you can see that it's not the poison of the material, it's the imbalance and the disruption in the body. And now think about hypertension and water weight. You know, you have bloatedness, and these people that experience this with high sodium diets. It's essentially the cells losing water to regulate the imbalance that you're creating in your body. I mean, there's deeper levels of understanding there, but in simple terms, that's it. It makes sense. So it's interesting, you know, there's no iodine in sea salt. There's no iodine in seawater that's measurable, which is why it had to be added to the table salt. But yet sea vegetables are the highest source of iodine in plants that I'm aware of. How does that work? You've got these sea plants growing in ocean water that has no iodine, yet the plant, I mean, just fix all of it from the ocean water? You know, it seems like you'd be able to find some if that were the case. I don't know. Sounds like alchemy to me. So, you know, here's another example. Worm castings. I don't know if you're aware, but worm castings are 10% higher in phosphorus than what they eat. How does that happen? Worms are highly bacterial organisms. Their gut has really high concentrations of soil microbes that make humus out of their manure, which is why it's different than cow manure. You know, cows have an anaerobic gut, not soil microbes, but gut microbes, right? So that manure needs to be turned into humus by the soil microbes. That's what makes worm castings so amazing, is that, you know, their manure is already humus. You don't have to compost it again, which again makes sense, right? So, you know, chickens can lay eggs on a restricted calcium diet. We'll talk about Kervran in a second. It's biological transmutation. So, you know, how does that happen? If the chicken doesn't eat the calcium, you know, are we truly what we eat? So, I mean, that's a good aphorism, but it begs a lot of questions. But the takeaway for me is that doesn't stop us from using worm castings and eating eggs. You know what I mean? It's like we don't have to know all of these things in order to leverage them to our benefit. So really important to keep in mind. And here's another book, and I'll make sure, you know, this is in the show notes, but essentially, you know, without getting too technical, what Kervran discovered was that there's a biological transmutation of potassium to calcium. So he had a substance that he fed to the chickens, derived of potassium. And what he found is that the chickens could lay eggs without any calcium in their diet in doing so. And it literally is what the name implies, biological transmutation. So another fascinating book. It's totally against conventional wisdom. And, you know, this is the idea from Kervran himself. He said, you know, my results look impossible, but there they are. I've taken every precaution. I've repeated the experiments many times. I've made thousands of analyses for years. Had the results verified by third parties who did not know what I was about. I have used several different methods. I've changed my experimenters, but there's no way out. We have to submit the evidence. Plants know the old secret of the alchemists. Every day under our very gaze, they are transmuting elements. I've been teaching chemistry at the Polytech for 20 years, and believe me, the laboratory which I direct is no den of false science. But I've never confused respect for science with the taboos imposed on intellectual conformism. That's a pretty powerful statement. And it means that unless he has gotten in rhythm with the intellectual conformism, most of the research is not funded, you know? And there's a book, The Body Electric, that I would recommend for you in that capacity as well, that describes the environment of which cutting edge counterintuitive research is done and not funded, just simply because it doesn't fit the dialogue that the powers that be want to have. I make every effort not to be cynical about that, but at this point, we really need to call a spade and really understand for ourselves that you know, become our own experts, right, and have experiences with these things and seek out these alternative forms of thinking, and you know, we can get a tremendous amount of value out of it. So I'll just reference this. I think it'll probably come up a little bit more when we talking energy here in maybe a month or so. But Ormus, if you hadn't discovered, it's a bit of a wormhole. You know, it's an acronym for orbitally rearranged monoatomic elements, or ORM. It's a, you know, good way to describe it. If you're not aware, the way we document data is based off a database that we put together. which presupposes that if we can't imagine and put it in the database, that it's not there. And that's what happens with Ormus. People send this material, you can make it by increasing a saltwater solution. Like, you get a lot higher yield out of whole ocean water than out of sea salts, but you can make it either way. And you increase the pH to 10.7, a white precipitate comes out of that chemically. And then you pour off the solution and wash that white substance 3 or 4 times to clean it. And that's a way of harvesting Ormus. The concept is that it's everywhere. It's just in different places in more concentrated ways, and there's ways in which you can concentrate it. Water traps, this process of raising the pH. There's a guy named David Hudson back in the 70s that is kind of said to have found Ormus for the first time, spent millions of dollars trying to figure out what it was, sent some to a lab, and they send a laser through the material, and the way the material expresses on the spectrometer defines the substance. And because it wasn't in the database, the spectrometer was saying there was nothing there. When, of course, the physical material is sitting there. It's a bit like, a figure skater pulling their arms in and spinning faster. So they're the same weight, they're the same person, but they're moving in a different way. And so this is a very surface reference here, but there's a listserv called the White Gold List. I've met a lot of really interesting people that I challenge you to seek out if you're interested. Again, something that we're not going to spend a whole lot of time on, but I did want to bring it up because of its relevance. It's, a lot of people call it the bridge between the physical and the spiritual in regards to matter. So, take some time and look into it if you're interested in that. And I think you'll be surprised at the least. So just drawing a couple of conclusions, think diversity and balance for the win. That's really, where you can draw the most relevance out of what the living system is capable of. Otherwise, it's restricted in ways that we haven't even thought about yet. Why would Mother Nature make an element not needed in the garden? I say that, I don't know. I wouldn't say once a day, but making sales calls and talking to people in the consulting realm, it's really important to think outside the box that we're given. If we only know what we're taught, we're not going to know a whole heck of a lot. So seek, and push those boundaries of what you're told and where it's supposed to end, and you can end up in some really cool places. And, in the end, have faith in the limitations of popular science. I don't think there's not anything more frustrating in the world than somebody who's got everything figured out, right? I mean, on that track, we've got too many experts in the world. Again, it's the first thing we should know is that we don't. And if you take that approach, you can learn a whole heck of a lot. And so on that note, a little reference of what we're going to talk next week is going to be weeds, pests, and disease. We're going to talk about the biological realm, food web, composting, compost tea in the coming weeks. Appreciate you guys being here and love learning from you. So if you got any references in regards to this information or any questions, I'm happy to take them.
All right, Evan, taking us down the rabbit hole.
Yeah, you got it.
All right, guys, now it's time for questions. Go ahead and ask your questions, and we'll get them over to Evan. If you don't know, you can support the show, keep it going by heading over to learn.permaethos.com, and in there you'll see progressive farming, and you can it's $29 a year. You get access to all of these recordings. You can download them. You can watch them anytime, as many times as you want, and we're just showing the latest 3 episodes is what you can find for free off of YouTube, but Evan made sure that we kept the latest 3 going, and that's great. Hey, looking through the notes now.
Yeah, I just see Ben talking about Spinoza and Kant. I don't know Spinoza.
Yeah, it really got, this topic really goes down or for me, it triggered the idea of peer review and how a lot of scientists are complaining about the peer review system and the grants. Because, so if you're a professor at, say, a university or at a research facility, and you get a grant to research something or to find evidence of something or to build something or create something, so now you're going to hire scientists to help you with that work, and And if scientists are finding contradictory information, they'll get fired or they'll get told not to work with that data.
Yeah.
And so, or if you were to say publish the information that contradicts the data, you may not ever get a grant again to do that kind of stuff, or you'll be ousted by the community, or you won't get published in journals. So there's a lot of it seems like there's a lot of directing on where science is going rather than being open to all possibilities.
Yeah, I think that's absolutely true, and a lot of it is understandable, from where we come from, and it's difficult to make it tact, but what comes to my mind is that book, The Body Electric. I can't remember the author's name. I'll look it up, but Becker, I think it was, but he was in the cutting edge realm of regeneration, and I don't know if you're aware of this. I wasn't until I read this book, but if up until the age of, I believe it's 9, I can't remember, if you cut your finger off above the first knuckle there, it will completely regenerate, and like a lizard tail or something like that, which was actually discovered by accident because they put a bandage on a child's hand, and a month later it was brand new, so that was just one of the anecdotes that he gave, but he was looking into the mechanism of the electrical mechanism of regeneration, and there's pretty startling insight just in this book, and half the book was his description of trying to break the veil of the conventional wisdom, and kind of what you were describing, and he couldn't get his research funded. And it was the same story, you could tell about, Gerald Pollack wrote the fourth phase of water book about the colloidal nature and the crystalline nature of water inside living cells and running up against charged substances. And the anomalies that he is documenting have been known for since the 1950s. The Russians were doing research. In the 70s, the French did. And their pioneering scientists spent, one of the San Giorgi, I believe is what it was in the French, spent his entire career investigating this, but couldn't ever get the research published because Nature publication would send out a team of scientists to their lab and replicate the data, which is understandable. But when they took the pure water that showed the anomaly through the experiment, at the end of it, it had traces of silica from the capillary tubes they were using, and it was contaminant. They threw it out, So the idea is like the metrics of which we told ourselves to determine truth limit the potential, and that's going to be the case, cynical or not. That's understandable. But what gets really difficult is when you see, profit get in the way and, ego and all of these things that are really restricting a lot of really cutting edge science, but they can't keep it in the box forever. I think that we're going to get more of that coming into the coming years. But yeah, I totally agree with your observation there.
Yeah, like a lot of stuff is like a lot of science gets stifled by politics and social and cultural, which can be good in some instances. Like there's some science that is detrimental to society, like some eugenics experiments that have happened in the past.
Right.
Which is what Spinoza was. Ben is saying Spinoza was an excommunicated Dutch Jew who was Einstein's favorite philosopher, and he said the totality of the universe is God and exists all at once, and every piece is an attribute of God. And I guess Einstein said he believed in the God of Spinoza.
Interesting. Einstein's a cool one because he's a really popular example of the further that you look, the less you know. Like the more faith you adopt, the further you penetrate, right? Like he was a very spiritual guy in regards to what's known about, his dialogue. Yet he's known as one of the greatest analytical scientists of ever. And I use him a lot, when trying to connect with people on this stuff because, he looked arguably further in his insight than anybody in those regards. And what he came to was exactly what Ben's saying there. It's really kind of interesting to think about.
Let's see. Elijah says, eat tarragon. It has higher amounts of iodine.
Tarragon has higher amounts of iodine? Higher than kelp, is that right? It's good to know.
Yeah.
Tarragon's, I think it's tarragon's been coming up a lot for me lately. It's also good for inflammation, I believe. Interesting. I did not know that about tarragon.
So back to the cultural sciences. Another big sciences that gets ignored or avoided, or would get not funded or shut down, would be things in the drug industry or psychotropic industry, like
Right.
I can't remember what DMT stands for.
Dimethyltrypto something.
Yeah, like that. But that was, well, I think it was back in the 90s or early 2000s when they finally did start allowing that to be scientifically studied, or at least one study was allowed to go with that.
It's legal in Oregon, actually, as a I think a religious ceremony sort of thing, because it was on the efforts of one guy actually that's kind of held the mantle for that. But there's a lot of, for lack of a better word, churches around ayahuasca and those types of things, and I'm pretty aware of that scene on some level, and it's really remarkable the amount of therapeutic benefit that it brings to people when respected, you know. And it's no different than cannabis, man. You know, I've been aware of it. I owned a hydroponics store, so I couldn't be, you know, unaware of it, really. And I'm absolutely positive that I had DEA agents come through my door and try to sting me because they were just way too obvious with their hippie shirts on, talking, you know, running their mouth. And I would always have to train my staff on how to handle that. And so I've been aware of it. And, you know, I've recently been using a CBD oil, and it's legal as a food supplement, not as a medicine. You can't make any medical claims, but only if it's less than 0.3 THC, which is known as hemp, and only if it's imported. That's what the 2014 Farm Bill says, which is just crazy. You know what I mean? It's like, how do you legislate this really completely documented therapeutic compound from a natural plant to that level? And it just, if that's not a perfect example of what you're saying, I don't know what it is. And to put my cynical hat on, because I consult a lot of people in the cannabis industry, the only reason it's really being legalized is because big business is posturing in ways to control it. And I say that from a high level of expertise. It's not just a thought. I mean, if you really understand what happens to a lot of the economies in these different states that are legalizing cannabis, you know, the devil's in the details. Legalization does not mean legalization. There's a lot, like in Washington, you can't grow a garden for medicine at home. It's against the law. In Colorado, you can grow up to 12 plants at home. That's a totally different posture, because in Washington, it's all big business, you know, huge. They're converting, you know, old Walmarts into indoor growing operations with like 3,000 lights. It's totally unbelievable. So, you know, the remnant of the control of business and profit, which again is understandable. It's kind of what the modern world's been built on, is, you know, I think it can only hang on for so long. I think it's going to crumble to some extent, and I don't know exactly what it's going to look like, but it is need to be able to connect with people that see those things in the same way. And I think that's a lot of the community that we're trying to build is people that can kind of not just do what they're told and look at it in ways that can be more progressive and bring more efficiency and value to what it is that they're doing.
Yeah, sorry about that. My up here.
Froze up.
Yeah, froze up there for a second. But that's a big difference between legalization and decriminalization, right?
Yeah, and you know, medicinal too. But it's, you know, I've been using the CBD oil and sharing it with people around me, and I just speak personally. It's absolutely incredible. You know what it does. It's undoubted. I'll put it that. It's not just a, you know, the power of the mind sort of thing. So, you know, plants are medicine in the end. That's the simple truth.
All right, Evan, I thank you very much. I am, my internet is going to crap, so I'm not going to be able to hang on, but you can continue if you like. If you hit that Q&A button, you can see you have a question there. People are still typing stuff. If you want to continue, just hit end meeting when you're done. I will stay on as long as I can.
Cool, man. Perfect timing.
All right.
And John, Korean natural farming, you know, I not as hip to that. I'm totally aware of it, but I will look into that. I think that part of that's going to have to, talk about fermentation, things like that. We're going to be talking about that in the biological realm. So next week we're going to talk about weeds, pests, and disease, kind of like back into some insight through the problems that we experience. And then the next week is after that is going to be soil food web and getting into composting, compost tea, difference between extraction versus aerated teas versus fermentation, and we'll definitely be referencing the Korean national farming as well and all of that. So yeah, man, appreciate everybody out there. Ping me at evan@farmprogressive.com if you have any questions, and please support the show. $29 a year. Share it with your friends. Thanks, y'all. Have a good day.